So coming to our basics, the NEET teaching is mostly focusing on the basics. We are back to our basics. So let's start our class with the physiology, which connects our pathology and pharmacology. Coming to the cell membrane, the initial topic, cell membrane, the fluid mosaic model. Cell membrane is based on fluid mosaic model given by Singer and Nicholson. The components of cell membrane based on this model is proteins. It constitutes of proteins 55%, lipids 40%, and carbohydrates 4%. So cell membrane is asymmetrical due to carbohydrates because carbohydrates are attached asymmetrically on either side. The highest protein is to lipid ratio is seen in presynaptic membrane. Presynaptic membrane doesn't have myelin. It has proteins but less lipids. This might be a question. And proteins, coming to proteins in the membrane, proteins constitute about 55%. Uh, Proteins can be divided into transmembrane proteins, peripheral proteins, and lipid-anchored proteins. What are transmembrane? They are present through the membrane. Examples are GPCR and sodium potassium pump. GPCR, it spans 7 times and hence known as son of 7. Under GPCR only, we have cyclic AMP and cyclic GMP mediated hormones. Sodium potassium pump is an ion channel. It is regulated by CFTR gene, which regulates the opening of chloride channel. Defect in this leads to cystic fibrosis. Peripheral proteins which are present on the periphery and provide structural support. In the RBC, it is ankyrin and spectrin which gives support to the RBC, which maintains the stability. Hence, the mutation in the spectrin leads to hereditary elliptocytosis. Ankyrin leads to hereditary spherocytosis. Skeletal muscle consists of a peripheral protein known as dystrophin. Mutation of dystrophin leads to Duchenne muscular dystrophy. Lipid-anchored proteins are also known as GPI-anchored proteins. Their example is IP3 lipid attachment seen in RBC. Those are CD55 and 59. Function is to prevent hemolysis. This comes under GPI protein if it's absent. Patient can present with paroxysmal nocturnal hemoglobinuria. Coming to lipids in the cell membrane, it consists of mainly 3 groups: cholesterol, which acts as fluidity buffer of cell membrane; glycolipids, present most commonly in brain and GI. 2 isoforms of glycolipids are gangliosides and cerebrocytes. As you all know, gangliosides, GM1 ganglioside, is seen in the GIT epithelium, which acts as a receptor for cholera toxin, and it is a PYQ also. Cholesterol acts as fluidity buffer of cell membrane. Fluid state, cell membrane fluid state is due to rich PUFAs. And lastly, coming to phospholipids. These are the most important responsible for the liquid membrane. Under phospholipids, we have around 5 examples. But phospholipids, when they are present in low concentration, they form monolayers. Example is surfactant. Phospholipids, when present in moderate concentration, forms mesides. Phospholipids, when present in high concentration, forms bilayer or lipid bilayer. Examples of phospholipids are phosphatidylcholine, which is also known as lecithin, which acts as a major surfactant. This was a question in NEET 2023 and is repeated. Sphingomyelin acts as minor surfactant. Lecithin is to sphingomyelin ratio when it is more than 2. It indicates adequate fetal lung maturity. Phosphatidylserine, normally present over inner cell membrane, but when exposed, it leads to apoptosis. Annexin 5 and phosphatidylserine complex activates apoptosis. Therefore, to determine apoptosis, annexin 5 staging is done. Phosphatidylinositol is IP3. It acts as a second messenger, IP3 TAG calcium. Cardiolipin is present in mitochondrial membrane of human heart. In syphilis, we test for anticardiolipin antibody VDRL test. Basic for VDRL test. Then coming to the junctional complexes, We have cell-to-cell junctions and cell-basement membrane junction. Cell-to-cell is connects adjacent cells. Cell basement is connects cell with the underlying basement membrane. Cell to cell, they can be tight junctions and gap junctions. Cell basement membrane is hemidesmosomes. Uh, Under this example is integrin. It attaches intermediate filament of skin with it attaches intermediate filament of cells with extracellular matrix, not skin. Cell to cell comes under cell to cell we have tight junctions and gap junctions. Tight junctions, example is desmosomes and zonular occludens. Desmosomes, they act as intermediate filament of one cell to they help in connecting intermediate filament of one cell to another cell. Helps in increasing tensile strength. Example, sites where desmosomes are seen are skin and gums. Zonular occludens, these are selectively permeable. Proteins forming zonular occludens are occludens, junction addition molecules. They are present in sites where we need selective permeability like blood-brain barrier, GI lining. Gap junctions. The other one in cell to cell is one is tight junction, other one is gap junction. Under tight junctions, we have desmosomes and zonular occludens. Under gap junctions, these are low resistance passages. They are made up of connexons. Each connexon is made up of 6 subunits of connection. Example, hard smooth muscle of GIT. Applied aspect of gap junctions are Charcot-Marie tooth disease. It presents as peripheral neuropathy due to defect in connexin 32, leading to defective myelination. And one more thing is idiopathic atrial fibrillation. Defective connexin 40, leading to defective gap